Okay, so let's take a look at rational functions, but also solving inequalities. Start with an example. First of all, we're asked to sketch the rational function, and then we're asked to solve an inequality. Just be careful, because sometimes, depending on the exam, they can actually just ask you to solve an inequality, and you need to really make sure that highlight this in your notes. If you get an inequality, you must use the sketch. Unfortunately, very often when people see an inequality like this, they try and solve it just algebraically, and that is not going to lead you to the correct solution. So for any sort of inequality in A-level maths or further maths, you really do want to be thinking about the sketch. Okay, and we'll see more on this when we move on to topics like modulus and quadratic rational functions. But just make sure you've got it clear in your notes that you want to sketch this. Okay, so first of all, hopefully we're getting good at this by now. We've got asymptotes, so vertical. Set your denominator, remember divide by 0. So we've got x equals 2. Horizontal. If we divide throughout by x, so we've got 4, 1 minus 2 over x, and then we can say, well, as x tends to infinity, minus 2 over x tends to 0. So remember, write it as an equation, y equals, don't say y tends to, y would equal, if that tends to 0 there, we've got 4 divided by 1. So y equals 4. Crosses the axis, so if x equals 0, y equals 4 times 0 divided by 0 minus 2. So we've got 0 divided by something, so y would equal 0. So actually, when this happens, I don't know if you've seen this yet, if x equals 0, y equals 0, we don't need to figure out, well, what happens when y equals 0, because guess what, when y equals 0, x equals 0. So the only point we know is that it goes through the origin. Okay, so we should hopefully still have enough information. If in doubt, you can always sub in a couple of values in, like x equals 1, and see what y equals, just to give you a bit more of an understanding of where the graph is. But we should have enough information. So we've got y equals 4, x equals 2. Essentially that means I'm going to need enough space up here, so y equals 4 could be up there. X equals 2. Could be there. And we know it goes through the origin. So that means it's got to be trapped in between those two asymptotes, and also up there between those two asymptotes. Remember, make sure you just get close to the line but don't touch. This is really hard for me to do this without smudging. Okay, and then you're looking for a nice bit of symmetry. When you draw this. Okay, so here's our sketch, and then the next part, we get an inequality. Okay, so if we look at this inequality, we know what y equals 4x over x minus 2 looks like. And essentially when you get an inequality like this, you want to think about the function y equals this and y equals 5. Okay, so we think about them as two separate functions, and then we can say, well, when is one bigger than the other? All right, that's how you want to solve inequalities. Treat one side as a function, sketch it. Treat the other side as a function and sketch it. Okay, so we know what this looks like. Y equals 5, we should hopefully know what that looks like. Y equals 5 is just a horizontal line, isn't it? Don't know why I'm doing a dotted line. Okay, so we've got the line y equals 5. And before we can do anything, like, we need to think, obviously we're being asked, when is the graph less than 5. In other words, less than means below, doesn't it? When is our graph below 5? The line 5 is here. We can see when it's below, but before we can do that, the first thing you need to do with an inequality is just solve when does it equal 5. So figure out the point where they intersect. So this point of intersection would be when this function intersects this function. Alright, so if we solve when they're equal to each other, we can then figure out the inequality. Multiply up, so we've got 4x equals 5 lots of x minus 2. Rearranging this, subtract 4x from both sides, add 10. So we get x equals 10. Okay. So that point there, where they intersect, would be when x equals 10. Okay. Now we've got the point where they intersect, and now we can actually look and think about what this is asking us, okay? Think about back in primary school or maybe junior school, the greedy crocodile points towards the bigger number. Okay, so we're looking for when the graph is below 5. And less than means literally we're comparing y values to answer this. So when are the y values below the y value of 5? You can highlight it if you want. Obviously, just be careful, right? If in the exam it says sketch and that's like one question, don't then draw all over the sketch. Like, make sure you get the marks for the sketch. And then if you want to do some working out on, maybe do another quick sketch so that you can shade in and solve your inequality. Okay, so you can clearly see that all of this part of the graph is below 5, isn't it? And also this part of the graph here is below 5. So the answer, the original question was asking us what x values make this less than 5. So all of these x values here are below when it's below 5. And if you look at your axis, your x-axis, these x values, which are less than 2, are going to give us values for the function that is less than 5. Okay, so think about your number line. The way I write this is I put the smaller number on the left, the larger number on the right. So when x is less than 2, you can see that our graph is less than 5. But that's not the only solution. We've also got this bit up here. So can you see that when x is more than 10, so if x is greater than 10, the graph is also below 5, because that's when it actually drops below 5 and approaches 4. So all of that section, if we carried on going for values bigger than 10, it would just be getting closer and closer and closer to 4. So obviously it would be less than 5. Okay, so we can say, and again, just be careful, don't mess this last step up. We know that the x values are larger than 10, so just put them that side. Okay, is it allowed to equal 5? No, it's not allowed to. So values less than 2, values more than 5. That's our solution. Sorry, before we move on, just a slight technicality. I think we should say or instead of and. Okay, and also you might see set notation in A-level maths. It's not a big part of the further maths, but it's just something to be aware of. They might write it in set notation. And or we'd use this. Okay. If you write those two inequalities down, you will get the marks for this question. Okay, so let's do one more example, and we're just going to jump straight into the deep end. It probably would be split up into more parts in the exam, but let's just imagine they were being like a really difficult, like particularly awkward, and just said, look, do all this in one, solve this. Okay, first thing we've got to realise that if we're solving an inequality, we need to consider the two separate functions, and we need a sketch. Okay, so we've got to think about y equals 1 over x minus 3. And we also need to think about y equals 2x minus 5. And we'll think about what they look like. Then we'll think about where they intersect with each other. And then finally we can look at the sketch and think, when is our rational function less than our linear function? Okay, so let's do a bit of work with our rational function. Asymptotes, x minus 3, so x would equal 3. Horizontal, we've got y equals, think about when x approaches infinity, we've got 1 divided by something really big. So y would equal 0. You can do the working out and see that you cancel down, but as x gets larger, 1 divided by large, y would approach 0. Okay, if x equals 0, y would equal 1 divided by minus 3, also known as minus a third. And if y was equal to 0, just be careful here. This is a bit of an awkward one actually. So if y is equal to 0, look what happens. We get 0 equals 1 over x minus 3. So if you were trying to figure out when it crosses the x-axis, and you said y equals 0, and you try and rearrange this equation, so we've got a fraction equal to 0, you might not notice. So if you multiply up, you get 0 times by x minus 3. Remember, whenever you get a fraction equal to 0, if you multiply up, it's just the top. So you end up with 0 equals 1. And you think, oh, I've broken maths. But the reality is, for this one, we've got an asymptote at y equals 0. So that there's never a solution to y equals 0. It doesn't actually cross the x-axis. Okay, this one, we've got a straight line, gradient of 2, and it goes through the y-axis at minus 5. Okay, so let's draw a sketch and see what we've got. Vertical x equals 3, horizontal y equals 0. Okay, so x equals 3, y equals 0. How are we going to draw this? You can't really draw it because it's the axis, but just highlight that. That's also an asymptote. Okay. When x equals 0, y equals minus a third. So now I know that the graph is going to be in this section and in this section. The more accurate you draw these with a ruler and a pencil, the easier this becomes, but obviously I'm using the whiteboard, so it's not that easy. Okay, so there's our rational function, and notice that it never crosses the x-axis, and that's why we got a little bit of a math error before, didn't we? Okay, for this one, you might want to, if you weren't sure about what this looks like, just sub in a few values. So if x equals 0, y would equal minus 5. And if y would equal 0, solving this, you'd get 5 over 2. Okay, so we've got 5 over 2, which is 2.5. Now I've got to be careful here, so 2.5 is a little bit less than 3. So we've got to make sure when we draw it, it goes through there before this point. And we've got a gradient of 2. And we can now see that there are 2 points of intersection between our linear and our rational. Okay, so there's no way that you'd be able to do this without a sketch. Okay, so now before I can think about when is the curve below the line, I just need to figure out where these two intersection points are. You could, even if you want to, before you get your intersection points, you could start to look at the inequality. So this is saying, when is our curve less than the line? And remember, you're looking at the y values. So here, the line is above the curve. So the curve is less than the line. So this is going to be part of our solution. Okay, here the curve is above the line. Here the curve is below the line. So this is going to be part of our solution. And here the curve is above the line. Okay, so we're almost done. We've just got to actually figure out what these coordinates are where it intersects. Okay, so when they intersect, when they equal each other, notice we're getting two solutions. And what type of equation gives us two solutions? Well, it's a quadratic, isn't it? It doesn't quite look like a quadratic yet, but realise that we need to solve this for x. So we want to, first of all, we want to remove the fraction. So if we multiply both sides by x minus 3, make sure you use a bracket, because we've got multiple terms, but we're multiplying both sides by x minus 3. Expand this out, we get 2x squared minus 5x minus 6x plus 15. How do you solve a quadratic? First of all, set it equal to 0. Okay, hopefully it factorises. If it doesn't, you can use the quadratic formula. Sometimes people get freaked out if it doesn't factorise because they think they've made a mistake. But you might get third solutions. Okay, let me just have a quick look. See if I can factorise this. Plus 14, so I know they've both got to be negative because the two minuses times together to give me a plus. Factors of 14, 2 and 7, yes, that's going to work, isn't it? If I put the 7 there and the 2 there, because that'll give me minus 4x, minus 7x. Okay, if you ever are going to factorise, make sure you just mentally expand it back out to check it gets back to what you started off with. So the solutions are going to be x equals 2, 2x minus 7 equals 0. So 7 over 2. Okay, so just check, does that like sort of tally up with what we were expecting? I know it's not perfectly to scale this sketch, but 2 is going to be somewhere here in between 0 and 3. Like mine looks a bit more like 1, but it'll just be to do with the scale I've used. So there's 2. And 7 over 2, which is like 3.5, is a little bit bigger than 3, which is that one over there. Okay, so we've got 7 over 2. And we've got that point there, which is 2. Okay, this is quite a difficult skill list. It takes a bit of practice, but like once you've got your sketch and you found where they've intersected, look back at your inequality. When is our curve less than the line? And in this section, it's less than the line. So these values here are the values that we want. Those x values there are when the curve is less than the line. These ones here as well, in this little section, are when the curve is less than the line. So we're going to be values between 2 and 3. And values bigger than. I've got to stop saying and, it should be or values bigger than. Okay, so probably practice a few of these guys. You will need to, because it's not like an easy skill. The good thing is we're going to see more on inequalities when we move on to the quadratic ones, so we'll get more practice. All right, thank you.